We are on lesson 14. We're actually almost done with unit 5. Just be aware, that's coming soon. But the goal today is to find the result of changing a number by a percentage. You'll know you're successful if you can find the result of applying a percentage increase or decrease on a quantity and write different expressions to represent the starting amount with the percent increase or decrease. I'm recording right now, just like always. Puzzle piece is lesson 14. And the next quiz will probably be in a whole week. So once we finish lesson 18, we'll do our last quiz of this unit, and then maybe like within a week after that, we'll take a test. So it's coming soon. Remember the incentive that I give you for doing well on your unit test. I mean, there's a ton of incentives I give you, but one that I think helps your grade the most is that whatever score you get on your unit 5 test, I will apply to any quizzes that are lower than that. So say you get like a 70% on your unit 5 test and you failed all your quizzes. Well, all your quizzes will be done to 70% match. That's a great way to improve your grade, making sure that you're going back, looking at your quizzes. They're usually viewable within a couple of days of taking it. Doing corrections from home, you can do on your quiz and then just take a picture and email them. You'll get points back that way. If you want to retake it for full points, you can come to tutoring today or every Wednesday after today. But those are your options for improving your grade. Not many people have taken me up on the quiz correction, so you know that's on you. Make sure we're ready for that unit 5 test. Additionally, in Schoology, there's tons of resources already have been posted for a while now, like the study guide. That's what your test will look like and illuminate, just different numbers. And then the other study guide, but for that constructive response portion. So there, we're almost done with unit 5. Questions on anything so far? All right. So on to the warm-up then. This is printed on your paper, so you should be writing everything I am. A scooter costs $160. The cost of a pair of roller skates is 20% of the cost of the scooter. How much do the roller skates cost? I'll take a volunteer this time. Luke? $32. Is that what the roller skates cost? Okay, let's see. Oh yeah, it is. Good job. Oh, for a second I thought we had this stop there.
I was right. Yes, I was. You're actually.
So how can we do that? Anyone? The math for it, Landon? Good. So why do we multiply it by 0.2 instead of by 20? All right, you have to convert the 20% to a decimal if it's going to make sense. If I do 160 times 20, that's way more than 160, and that wouldn't make sense for this answer. So if you don't know how to convert decimals to percentages, how could I, or sorry, percentages to decimals, how could I do that? Divided by what, Julian? No, we can't divide by zeros. Dividing it by 100%.
Yeah, that's what
That gives you the equivalent decimal. All right, so good. So times that by your total original price, and that gives you what you need. Questions on that? Well, at least for this one, it gives us what we need. Number 2, a bicycle costs 20% more than the scooter. How much does the bicycle cost? All right, Brian. $192. Anyone disagree? All right, so this one has the same percentage involved, but we have a different answer. So a bicycle costs 20% more than the scooter. So we know what 20% of the scooter is. What is 20% of the scooter? More than tells us to do what? And we're adding it to the cost of the, which is 100%. Have that together, that's how we get the 190. Questions there? Trying to think that was more like a dollar. All right. Last one. Let's try to get some different hands up than the ones that are in there. So a skateboard costs 25% less than the bicycle. How much does the skateboard cost? Galen? $120. Anyone have something different? Landon, what do you have? Huh? Any other answers out there? All right, so then let's problem solve it. A skateboard costs 25%. What's the decimal for 25%? And it's 25% less than the bicycle. So what are we multiplying by? 192. Because it's of the 25% of the bicycle, not the scooter, which is how I looked at it earlier on accident. So yeah, read closely. It's 25% less than the bicycle. So you multiply it by the bicycle cost. Throw that in your calculator. I don't have these calculations known by heart yet. So 0.25 times 192 is 48. Now, does that mean that the skateboard costs $48? It's the skateboard costs 25% less than. What operation is less than? So is it going to be 48 minus 192 or 192 minus 48? Good, which is what? Good. All right, so whenever you see less than, I mean, depending on the situation, yes, it can be an inequality too, but in this situation, it's subtraction. But also the word than, I call it a switch word because you switch the order. All right, normally you can just go from left to right when you're like translating stuff. But whenever you see less than, make sure that you're subtracting that from the other cost instead of just left to right. Because when you do 48 minus 192, what's wrong with that answer? It's negative, and that wouldn't make sense. Like a skateboard wouldn't cost negative $. Correct. So, but yeah, also reading it close. So questions on the warm up. All right, pretty impressed so far. These are real life skills. If you don't know like what exactly you're paying for, you could be taking advantage of. So that's why you need to know like your percentages and all that, or how to find them. All right, three more similar problems. Try these now. So you need to pay 8% tax on a car that costs $12,000. What will you end up paying total? Burritos are on sale for 30% off. Your favorite burrito is normally $8.50. How much does it cost now? A pair of shoes that originally cost $79 are on sale for 35% off. Does this expression represent the sale price of the shoe in dollars? So I'll have you try those with your group and make sure you come to an agreement. I'll give you like 5 minutes. Okay, school 2. What did they end up paying total in number 1?
Oh,
960? Is that what they ended up paying for the car class? What is the 960?
I thought I come back.
That's the tax only. How do I find the total cost of the car? Add it to also what the car costs. So it's always like, what is the prices plus the tax, which gives me a grand total of what? Oh, okay. Sorry, I thought it was about this. So good. Table 3, burritos are on sale for 30% off. Favorite burrito normally costs $8.50. How much does it cost now? $5.95. Anyone disagree? Okay, that is correct. So because, we need to figure out what 30% off is of $8.50. How can I figure that out? Table 4, how can I figure out the 30% off of the $8.50? Multiply what? We're on number 2. So the question was, how can I figure out what 30% of $8.50 is?
Oh, sorry.
Okay, good. That's what you would multiply to figure out what the discount is. When you put that in your calculator, what does it say, class? The 8.5 times 0.3. 2.55, you said? And then the way I figure out my cost now is to do what? Would a discount add to the cost or decrease from the cost? So then it should be the original minus the discount. All right, and that's how we're getting the 5.95. Questions there? All right, so make sure if when it asks for reasoning, either show work or write a few sentences. I think showing work is sufficient enough. Table 6. A pair of shoes that originally cost $79 are on sale for 35% off. Does this expression 0.65 times 79 represent the sale price of the shoes? Yes or no? So yes or no on number 3?
No.
Okay, no. What do you think represents the sale price of the shoes? Felt good? What? Okay, so the question was, is it 0.35 and then what? Is that it? What do you do with that 0.35? So would that give me the sale price? Okay, so if the 0.35 times 79 doesn't give me the sale price, what does it give me? It gives me. You think the 0.35 times 7.9 gives you the price of the shoes? That would be my discount. So that's what the discount is, the 27.65. But is my discount the same as my sales price?
No.
No, so this, the 0.35 times 7.9 doesn't give me my sale price. Does, the 0.65 times 7.9 give me the sale price? Jalen? Okay, so we're changing the no to a yes. All right, because what is the sale price? Table 7, what is the price of the shoes now? $51.35. So take your original price, which was $79, subtract the discount. That sounds right. Let me just verify. So 79 minus the discount, which was 27.65. That's what the shoes cost now. That is my sale price, the 51.35. The question asks, so this right here is my sale price. The question asks if 0.65 times 779 represents my sale price. Does it? Class? Yes. And if you want to verify in your calculator and do the 0.65 times 79, you do get the same amount. So instead of like figuring out what the discount is and subtracting it, you could also figure out what remains of the cost, which you get from 1 minus what 0.35 is. All right, you get 0.65 and then times that to the total cost. So that's another way of getting the same answer, sale price, maybe even a faster way. So that's pretty good. Questions on number 3? All right, we're almost done. So next, we're practicing with percentages, but we also need to kind of relate it to our growth and decay function. So on the back side, you have a chart that you're filling in. We'll do a couple together. But remember, when it's growth, it's usually 1 plus whatever the growth rate is. When it's decay, it's usually 1 minus whatever the decay rate is. So kind of use that to help you. So when I am completing this table, they want an expression for how you can figure out what the cost is now. But then they also want one where it's only with multiplication, like how we did in number 3. So let's try that. A 1-night stay at a hotel in Anaheim costs $150. Hotel room occupancy tax is 15%. What's the total cost of a 1-night stay? So they already have it partially filled in. Here's my original cost for just the 1 night, right? And then you would need to figure out what 15% is of that, and then add it back to the original cost. To write that only using multiplication, think, would the tax add to the cost or decrease the cost? So let's look at like the 1 plus the rate. So what's my rate? Well, the rate is the 15%. What's the rate as a decimal? If you add the 1 plus the 0.15, that gives you 1.15. And that you can multiply by the original price to get, your value, like what you're paying. Does that make sense? Maybe, maybe not. All right, we'll keep practicing with it. In this one, let's look at a decay example. So teachers receive 30% educators discount at a museum. An adult ticket costs $24. How much would a teacher pay for admission into the museum? So would the discount add to the cost or subtract from the cost? So then it should be whatever my original is minus, and then we need to figure out the 30% times 24. But in these, you don't actually have to figure out, you're just writing the expression. So what would I multiply together to figure out what 30% of 24 is?
One minus one.
All right, so don't look at the right side column yet. Just listen to what's going on. That's happening. So how can I figure out what 30% of 24 is? What am I multiplying together to figure that out?
24.
24 and 0.3. That would give me my discount, and we're subtracting it from the original. That's what you're doing in the expression 1 column. In the expression 2 column, you're just using multiplication. So why did they have a 0.7 right here? If there's no like 7 in the problem even, how did they come up with 0.7? Good, since it would decrease from the cost, the way that they got that was doing 1 minus 0.3. That gives me what remains. So they're paying 70% of the ticket. And then you times that by 24, and that gives you your price. Questions? Okay, so then try filling out the rest of the table using that method. One of them has a blank for the description. All right, basically come up with whatever you want to put there that would make sense for the given expression. So just do your best. All right, so voices off. We did the first 2 together. We're on the 3rd row. So the population of a city was 842,000 10 years ago. The city now has 2% more people than it had then. What's the population of the city now? So is it growing or decaying in that one? That's why we put a plus sign in the first column right here. Okay, because the additional 2% adds to the number of people. So plus whatever 2% of 842,000 is. You don't necessarily need to like simplify that, just to know how to get it. Then if you want it to just have multiplication, no addition, you could do that by following those functions I told you. Since it's growing, use that one that has the plus sign in it as an example. Initial amount is 842,000. The 1 plus the growth rate as a decimal is how we get the 1.02. That's like 102% of what we have originally. And there's no exponent for the t written. Why do you think that is? How much time has passed? Well, that's what it, well, I guess, yeah, I guess that's kind of normal about that one. I was gonna say because it was 1 that passed, but really it did pass 10 years ago. But it's not saying that it increased 2% every 10 years. It just says it increased 2% from then to now. So that's why we only have it there the 1 time. Okay? So remember that. Questions on that row? All right, so now this one. after a major hurricane, 46% of the 90,500 households on an island lost their access to electricity. How many households still have electricity? So if they lost their access, would that add or decrease the amount? That's why we have a minus here in the first column. Here's my original minus whatever 46% of the original is. To have it where it's just multiplication, I would have to write it like this instead. Where did that 0.54 come from? Good, so since it's decreasing, we're looking at the decay type of the equation. So 1 minus the rate that lost it gives me 0.54. And it wanted to know how many still have it. So if 46% lost it, 54% still have it. So you would figure out whatever 54% of the original was. Make sense? All right, this one you could have filled in whatever description you want, as long as it had that it was decreasing by about 21%, so that would be the equivalent decimal of 0.21. So you could say you had $754 and you spent 21% of it. Now this is what you have left. The equivalent one that would be just multiplication is what remained. So if you spent 21%, what remains would be what percent? 79%. That can give you what you currently have. Questions on that one? All right, the last one was more of a challenge, but it's also more like what we've seen in our examples for exponentials. Because usually we're looking at a change that's happening every year versus just the one time. So that's why it's in brackets, because it says the number of students in a school was 150, then it grew 8%. So that would give me the first increase. And then it grew another 8%. So you can't just double it to make it like 16%. You can't do that. That wouldn't make sense, and that wouldn't be the same answer. You have to figure out what it was after increasing by 8%, and then increase that value again by 8%. So questions on that? All right. The reason why the expression in red looks different is because it happened twice where it increased by 8%. So here's like 108% of the 150, and then times it by another 108%, and you get the now current after 2 years. Or you can make it with an exponent, and that shows the change for 2 years time. That's like our exponential function. That very long. Questions? All right, so make sure if you have questions on this, let me know. But you have plenty of time to work on your puzzle pieces. We did lesson 14 today. So now's a great time to do quiz corrections, to work on your practices and ask me questions. But that is all for the lesson.